Rational exponents. Well, there's not really a whole lot to say about rational exponents because all kinds of exponents really obey the same laws, the same properties that we have already seen. So there's really nothing new to this, not a lot. So, but we haven't really done much with them. So we're gonna do some examples where we tackle them, like do stuff with rational exponents. So rational, remember the word rational means fraction. So rational exponent is just an exponent that is a fraction. And we have already seen special types of rational exponents, namely when the fraction looks like this, when it is of the form 1 over n, because having a rational exponent of that form is the same thing as the nth root. Alright, so for example, remember that 1 x to the 1 half means the square root, and usually don't write that too, it's just that. And then x to the 1/3 would be the cubic root, and x to the, let's say, 1 over 7 is the 7th root, and so on. Alright, so we know what it means for an exponent to be a fraction when the fraction is of that form. In general, when the fraction is of the form m over n, what does that mean? Well, using the laws of exponents, because m over n is really the same as m times 1 over n, we can say then that this is the same as x to the m, so you do that first and then find the nth root, or you can say find the nth root first and then raise it to the m power. I'm assuming here m and n are integers. Alright, and that's it. Either one works. They give you the same thing. So that's what it means then for what it means when you have an exponent that is a fraction. All right, so let's do some fractional exponents or rational exponents. Uh, Most of the time you do this with a calculator, but it is good to do at least a few of them by hand, just because doing them a few of them by hand when the numbers are small helps you understand what's going on. So I'm gonna do the first two without a calculator, and really all of them without a calculator because the numbers are small, so you can really do this without a calculator. So for example, the first one says 8 to the 2/3. So what does that mean? Well, 8 to the 2/3, according to this, means either 8 squared to the 1/3 or 8 to the 1/3 squared. And you can do either one. If you do this one, 8 squared is 64, so it would be 64 to the 1/3. If you do this one, it would be the cubic root of 8, right? That's the same thing as the cubic root of 8. But the cubic root of 8 is 2, so that would be 2 squared. And 2 squared is 4. So note that, I mean, this was easier than this. What if I ask you what is the cubic root of 64, it might not be entirely obvious that it is 4 unless you have that memorized. But however, doing it this way was easier. You didn't need a calculator. So in general, I would suggest then that doing the root part first and then the numerator part is the way to go when you're doing this without a calculator, instead of the numerator part first and then the denominator part, because this makes the numbers big real quick. So the way I would do this then is usually would always be I do the denominator part first and then the numerator part. So I interpret that as 8 to the 1/3 squared. And now, as we just said, the to the 1/3 really is the same thing as the cubic root. The cubic root of 8 is 2, so that would be 2 squared, which is 4. And that is the answer. Okay. All right, let's do the next one. This is similar. So 4 to the 3 halves. So then 4 to the 3 halves will be 4 to the 1 half, doing the denominator part first, and then to the third. 1 half times 3 is 3 halves. All right, 4 to the 1 half really is the same thing as the square root of 4. The square root of 4 is 2, and 2 to the third is 8. So the answer is 8. Okay? Now, part C and D are just more practice with exponents. So all the rules that we have already learned for exponents work exactly the same way. So let's do this one. It says x squared y to the negative a fourth, all that to the eighth power. That's the numerator. Then denominator x to the negative 4 y to the sixth, all that to the 1 half. Okay. Um, First, I cannot really move in things that have negative exponents to the bottom just yet, because this thing that has a negative exponent is inside these parentheses, that is affected by this exponent 8, so I cannot just really get it out of there and move it, because it's trapped in that parentheses. I cannot just pull it out of there and move it down. So the first thing you need to do that we're going to have to do is distribute the eighth power first, and then this half power first on the bottom. Then there will be no more parentheses, and I would be free to move any negative exponents around. Okay, so let's do that first. So distributing the eighth power across the top, that's the same thing as x squared to the eighth. So everything gets raised to the eighth power. So x squared gets raised to the eighth, and y to the negative fourth gets raised to the eighth. And then for the bottom, I'm going to distribute the 1 half power. So x to the negative 4 gets raised to the 1 half, and y to the 6 gets raised to the 1 half. So now, using the properties of exponents here, x squared to the 8th, that would be 8x to the 16th. You multiply the exponents. And negative a quarter times 8, negative a quarter times 8, that is negative 2. Okay? On the bottom, negative a quarter times a half, that is negative 4 times a half, sorry. Negative 4 times a half is negative 2. And then 6 times a half is 3. So we get that. Now we're free to move things around, because now they're not trapped in a parentheses. They're free to move. Variables have negative exponents are going to move down, that if they're on the top, and the ones that are on bottom move to the top. So now this is going to be x to the 16. The y to the negative 2, that moves to the bottom as y squared. The x to the negative 2, that moves to the top as x squared. And then you have on bottom also the y cubed. Okay, and now combine what you can. I can combine these x's, x to the 18th, adding the exponents, and on bottom you have y to the 5th. Okay, and that is the end. Okay, and here's one last example. Um, on this. So it says negative 8 r squared, all of that to the 1/3, times negative r to the 1/4. Okay. First, distribute that 1/3 power. So that means the negative 8 gets raised to the 1/3. And then the r squared gets raised to the 1/3. And then you still have this um, negative r to the 1/4. Okay. Negative 8 to the 1/3, that really means the cubic root of negative 8. And then here, you can use the property of exponents that says you multiply them to simplify that. So 2 times a third is 2/3. Okay, and then there's nothing to do here, so I'm going to write that. This is our multiplication. The cubic root of negative 8 is negative 2. So negative 2. Okay, and then let's see, finally, multiply the coefficients. This is like a negative 1 in here. We usually don't write 1, negative 1, but there's an invisible one there. So negative 2 times negative 1, that would be positive 2. And then you have these r's that still need to be combined into a single r using the properties of exponents. And the property says you actually, in this case, add the exponent. So that would be 2/3 plus 1/4, and you can do that either by hand or use your calculator. Not a problem. I'm gonna do it by hand, just because it's good to review that stuff. How to add fractions by hand. So 2/3 plus 1/4. And we need to really review this because this is going to come up soon, actually. We're going to be adding fractions with variables. The procedure is exactly the same. Okay, first you think of the least common denominator, the smallest number that is a multiple of both 3 and 4. So it's the smallest number that fits both of them, 3 and 4, inside as a factor, which in this case is 12. 12 is the smallest number in the multiplication table of both 3 and 4 at the same time. All right, so that means the new denominator is going to be 12. And then you think, what do I need to multiply these 3 by in order to get 12? Well, you need to multiply by 4. Whatever you do on the bottom, you do to the top. So multiply top and bottom by 4. That's going to make that 3 a 12, which is what I want. And then to make this 4 into 12, you multiply by 3. So times 3 top and bottom. Now, 4 times 2 is 8. And then 1 times 3 is 3. Once you have the fractions have the same denominator, you just add the numerators across the top. So that would be 11 over 12. Okay, so that means adding 2/3 and a quarter gives you 11 over 12. So the final answer here would be 2 to the 11 over